Hello everyone, reporting today for Fun Robotics Network. I'm Abbas, and with me here is Team 21239, All Systems Go, from Louisville, Kentucky. This team has been absolutely incredible this season, currently undefeated, 18-0, all the way through the Kentucky Championship, Inspire Award winner, winning Alliance captain. I think every single match they've played has been a top 20 Kentucky score, which is just insane. I think there's so much to learn from this team for all of you out there who are looking to have really fast slides with a long horizontal extension on top, and I just can't wait to get into it with All Systems Go coming up on Fun Robotics. All right, guys, so, you've had a very successful season. I just want to start real quick with your game strategy. When you first came into the game, what were your initial thoughts and how did that influence your robot design?
Yeah, our first thoughts was similar to previous games. There are two pretty clear roles that robots might take. They were both samples and specimens, and it was a pretty clear divide. So we thought originally teams were either going to choose to do samples or specimens, and what our strategy is we really wanted to be able to play around that and be the best alliance partner we could. We wanted to be as competitive as possible at samples and also still good at specimens. So that sort of drove the decision for a lot of the different things on our robot here.
Cool. And starting with your drivetrain real quick, there's just like two very unique things I want to say. Like, first, I see your wheels don't seem to be supported from the outside. Is that something like you didn't feel the need to do that? What drove that decision?
Yeah, so we're running a pretty standard straight chassis drivetrain, and yeah, no, the wheels are not supported on the outside. It has historically been fine for us. We haven't noticed any problems with wear, as they are constrained pretty well, and the robot isn't too heavy. And a couple cool things about the drivetrain is, a couple main things about the drivetrain actually is we chose to use a strafer chassis just because it's given us a level of customization that we couldn't do with parallel plate. We ran parallel plate last year, and a couple things we noticed were all the electronics inside were pretty hard to access, and maintaining things or swapping out motors was tricky. So it is just a spray painted strafer chassis that we're running, standard mechanism drive, just with the Go Build It clamping miter gears here.
Cool, yeah, and just touching on that spray paint real quick. Black Go Build It channel, super sick, so just all of it spray painted, no powder coating or anodization or anything like that?
Yeah, pretty much anything that's painted black on the robot is just spray paint. It has worked for us, and we have found some pretty good spray paint at Home Depot that has it's pretty scratch resistant, so that's what we really like to use.
Okay, cool. So getting into your lift, while you had that undershot of the robot there, I saw it was only 2 motors, which is pretty insane to me considering how fast your lift is with how much you have going on, like with the horizontal extension and everything else mounted to it. So walk me through how you're able to get it so fast. I see some torsion springs maybe down there. Just walk me through the counter springing, because that's nuts.
Yeah, so early on in the season, our lift was really slow. It was 223 RPM motors. And it was slow because those were the highest RPM we could use just because of the amount of weight we have. We have about 8 pounds on the top assembly that we have to lift up, so we needed a lot of torque. So we tried a bunch of different methods of counter springing, and eventually we landed on this torsion spring design, and we sort of call it counter springing for dummies, but it's worked really well for us. Here we can zoom in on the torsion springs just a little bit here. And so the way it works is there's one fixed end of the torsion springs that's in this channel down here, and then there's one floating end. So as the slides go up, the torsion springs release the energy into this shaft, and it goes directly onto our main slide shaft. And right now we're running 2 16-inch-pound torsion springs on here, and that allows our lift to not only be a lot faster because now we can use 435 RPM motors, but it also allows it to hold position without any power. And so that's been really big for us this season.
Awesome. Yeah, so ton of questions there, Caden. First, really cool stuff. I see you have just that massive gear connected to like the little spur gear on the shaft. Was that just so you have less than 1 rotation on the output there for the torsion springs, or is there another reason behind that?
Yeah, so the reason for this was these springs are only rated for 1 rotation. We do go a little bit beyond that, but also the diameter of our spools, since we're running 5 stages, and because this is on a 5-to-1 ratio, we wanted the springs to make exactly 1 rotation. So the spools are just the right amount in circumference so that each rotation is lifting up 1 stage of slides. And that's the golden ratio, so that from full extension to full retraction, the springs make 1 full rotation.
Cool, yeah, and I see you throwing around a ton of numbers there. You mentioned the 223 RPM, the 16 inch-pounds. So was there a lot of calculations that went into this torsion spring, use and design, or was it more just kind of trying a couple different sizes? Like, walk me through that.
Yeah, a little bit of both. We weighed the top assembly that we have here and found it to be about 8 pounds. And so what we did is we just looked up the formula for calculating the inch pounds we'd need to rotate on the shaft. And by doing that, we were given a couple different numbers. And so we ordered springs in a bunch of different sizes and just tested out which ones worked best. Obviously, there's things like motor resistance, friction, all these different things that add up. So of course the calculations didn't add up perfectly, but it was really great for us because we were able to swap out the springs really, really easily. And that made it so we could quickly just iterate, and get to where we have now with 32 inch-pounds of force.
Awesome. Yeah. And so, last question with that, you mentioned you started with those 223 RPM lift motors, and teams, I think, like on the higher end, typically run like around 1150 RPM. So have you since been able to bump up that RPM, or are you just more using the torsion springing so you have much less power draw from your battery?
Yeah, since we countersprung the lift and also made the top assembly a little bit lighter, we were able to switch from 223s to 435s. Awesome. And so that's been a lot nicer.
Yeah, that's fantastic. And now moving on to your horizontal extension. So yeah, I see you have this massive horizontal extension assembly up there as well. And it's one of those really cool designs with the large spool driving everything. So walk me through kind of the powertrain there and why you went with that spool as opposed to linkages or something we've seen from other teams.
Yeah, this was a pretty controversial decision to use these large spools instead of using a linkage. A linkage was our first thought, and it was sort of what we would have preferred, but it was something that we knew it would have required a couple different iterations, and through testing, we would have needed a massive linkage to reach the full 21 inches of extension. So we stuck with stringing just because it was what we had experience with, and it was something that we could get to the finish line pretty quickly. So we're just running two Axon Max servos on a servo power module up here, and so that's allowed us to get that pretty quick extension. It is a little bit slower than a linkage, but the thing is, we extend the slides as we're driving back into the submersible, and we really never find ourselves needing that extra bit of speed because it's always just fully out when we're intaking.
Yeah, and on that topic, clearly you have the design capabilities to make a system that deposits out the back, but watching your guys' matches, I notice you only work in the front of your robot, right? So you're hitting that 180 degree or 135 degree turn every time you go to score. And so what was the reason behind keeping that front facing deposit and intake structure as opposed to a pass-through design?
Yeah, so this is what we started the season with. It was something that we knew we could get to the finish line pretty quickly and that it would work 100% of the time. There wouldn't be any errors with flipping it back and forth, and it was super, super simple. One of the things we've noticed is we haven't really needed to pass through a lot of the times because as we're intaking, we find ourselves rotating right, and so we're ending up only making around a 90-degree turn. And one of the cool things, we have a couple different software things that also help improve that speed, but it was just also saving weight on the top assembly as well. If we chose to do a pass through with linear rails or another design, it would have taken up more servos and a little bit more weight.
Yeah, absolutely. And on the topic of servos and weight and things like that, I feel like your wiring is very clean going up to the deposit, and I know that's something teams have struggled with a lot. The force and the weight due to the wires themselves can really slow down the lift. So walk me through what you have going on there, what's enabled it to be so clean and so fast.
Yeah, so our wiring, a pretty cool thing, I'll spin the remote around here. We use terminal blocks on our wiring, and that allows our wiring to be super robust, and it also makes it super easy to diagnose any problems we have. So we have these terminal blocks up here, and we have them down here, and they have quick disconnects on them, so it allows us to snap them in and out pretty easily. So how it works is we're running the cables with connectors down here on this end, and then going up here is just regular 22 gauge wire that we have up here, and then it just ports into this connection up here, screws in there and clamps on, and then we're running connectors back up here. And this has been great for us because we haven't needed to run big long wires with connections all the way out, both up and out on our slides. And it also makes it a lot easier to diagnose problems because we can trace really, really quickly back to, okay, we're not getting voltage here, what's going on? We can figure out exactly where the breakage is and repair it.
That's incredible. Yeah, I think teams could could really benefit a lot from that. And now, like with the Rev Servo Hub coming out, is that something you envision using with your robot for like a Worlds rebuild or some changes for Worlds, or do you think you're really secure with this terminal block setup, so you won't need to do that?
Yeah, we're planning on, for the Worlds robot, we're planning on switching. We're planning on staying with the Rev Servo Power Module here. We considered switching to the Servo Hub, but it hasn't been out for a while, and we don't exactly know how to use it yet, so we don't have one yet. But definitely for next season or some off-season events, we'll look at it because we've heard good things so far.
Cool, yeah. And now going on to your intake very briefly, it seems like simplicity is key there, and that's what really makes it work well. Is there anything you want to highlight that you think teams could really benefit if they're looking at new intakes for later competitions?
Yeah, our intake, yeah, you hit the nail on the head there. Simplicity was key. We tried a claw originally and then surgical tubing intakes, but we eventually landed on this design because it can intake both samples and specimens. There is a color sensor in the intake too. We didn't get a chance to use that at States, but we're currently working on that right now for a cycling auton. And yeah, it's powered by 2 servos here. The choice behind that was we could package it a lot better and it was a lot more compact. So we just chose to stick with that. It didn't add that much weight having the servos up there. And then it's just running these 48mm Go Build the Gecko wheels. And the key for us was how fast our intake was really depended on the center-to-center distance of these wheels. The farther they were apart, it couldn't grip them as well. And so now when we have it intake, it fits the block right nicely in the center so that it can't come out pretty sturdily until we spit it out.
Cool. And so with that, you never really needed any like springing or any compliance there? Like it was just the compliance of the wheels was enough?
Yeah, for us, the compliance of the wheels was enough. We found that since we're running 2 Go Build super speeds, they have plenty of speed on them to grab the blocks. And the key thing for us was making sure to clean the Gecko wheels, as we found that just having clean Gecko wheels makes the intaking a lot faster.
Cool. And I feel like one issue where thing that can be a pain point for teams with these types of intakes is you need like a really kind of larger area for the intake to sit down behind the block while you're going into the submersible zone. Is that something you face trouble with? And if so, how have you overcome it?
Yeah, that was definitely a consideration for us, as we noticed that as blocks get pushed around later in the game, there's a lot that end up built up towards the areas. We haven't had too many problems, as the competition that we've been around so far, there haven't been too many, there's always been blocks in the middle. So we've been pretty lucky for that. We are planning for Worlds or some off-season events to work on adding a sweeper and sort of a hybrid pusher. And that is definitely something we are taking into consideration, as at the later levels, there will be pretty much no blocks left. So we'll have to make sure, when it's down, it does take up a pretty significant amount of area. It's about the size of one sample that it takes up. So.
Cool. Yeah. And, as we wrap this up, looking forward to the World Championship. You guys have already qualified, so huge congrats on that. Are there any plans you want to talk about, things you think teams should be looking out for as far as strategy goes, and things you're considering when you're working on improving your robot for as good of a performance as you can have at Houston?
Yeah, we're definitely going to work on our game strategy a lot more, thinking about how the game is going to be played at Worlds. We definitely think it'll be a lot more aggressive, maybe a little defense happening. So hopefully we're going to beef up our robot a lot more, make it all ready for robot-to-robot contact, and keep improving and doing a lot of drive practice along the way.
Yeah, and on that topic, is a level 3 hang something you see is like a must-have? Is that something you're really prioritizing, or it's kind of like your level 2 is fast enough, you think you'll just keep that as it is?
Yeah, we did a trade-off analysis, and we actually made a level 3 hang for this robot, but it was pretty scary. The robot took a tumble a couple times, so we're probably just going to stick with our level 2 hang. It's been pretty quick, and we're going to speed it up a little bit more too. It's just something that's worked really reliably for us, and we've got it to be pretty consistent. Awesome.
Yeah, well, all systems go. Thank you guys so much. I mean, your robot is just awesome. I think there's so much information in here that will really help teams. So, that's why we do Behind the Bots, and I think you guys totally deserve one. I can't wait to see how you do in Houston. Hopefully you continue the undefeated run, but it will be a tough competition. So yeah, thank you guys so much. Reporting for Fun Robotics Network, I'm Abbas, and this is Team 21239. All systems go.